Hi, my name is Alusain Barry. Welcome to this lesson on differentiation of implicit functions. Earlier, we defined what implicit functions are, and we looked at the steps on how we can we can differentiate implicit functions. We define implicit functions as functions in which it's difficult to express any of the variables in terms of the order. Okay, if you look at functions such as these ones we have here, or these past examination questions we have here, you can see that it's really difficult. Let me pick up a pen, like for us to isolate x or y on one side of the equation. We tried it earlier, we saw that it's extremely difficult. Okay, to differentiate such functions, what we do, we follow these steps we highlighted earlier. Okay, you differentiate the function term by term, and then you make dy dx the subject of the equation. Okay, in differentiating term by term, there are two things you have to pay attention to. Okay, and these two things are basically how you differentiate functions in y, terms in y, and also how you should take care of products and quotients. Okay, let me scroll down quickly. We did note these ones. Okay, so whenever you see, for example, for the first point, we have, whenever you say, for example, you have 3x squared plus um, 3xy plus y squared equals to 5. Say, for example, this is the implicit function we are given. Okay, to differentiate this, say let us focus our attention on this y squared. So whenever you see such a term in y squared, what you do, you differentiate the term, and then you multiply by dy dx. Okay, so you differentiate the term times dy dx. So for example, the derivative of this, differentiating this term by term, would give us, say for this term, we say because we multiply the whole term by 2, and then we subtract by 1, as we always do. Okay, so we say 2 times y, 2y, 2 minus 1 is just 1. Okay, so we just leave it as that, but then we multiply it by dy dx. So this would be 2y dy dx. Okay, so this is it. Say for example we have 3 y cubed. Okay, to differentiate this term, what you will do, similarly, you multiply the whole term by the power, and then you subtract 1 from it, but you multiply by dy dx. Okay, let me just use another ink. So we say here this will be 3 times 3 will be 9, y 3 minus 1 is 2, so 9y squared dy dx. Okay, so this is how you differentiate such terms. This is one area you have to pay attention on. The next point you have to think about is how to deal with products and quotients. Okay, whenever you use for such terms where you have a product or a quotient, these ones are quotients. Okay, with divisions. Terms that are just multiplications of other terms, you use the product rule. Remember the product rule. For the product rule, what we do, say product rule. For the product rule, we say dy dx is equal to, we hold the we differentiate, we hold the second term, say for example here y, and then we differentiate this first term. So the derivative of x squared would be 2x. Okay, plus, and then we hold the first term again, now x squared, and then we differentiate the second one. Here, remember, if you are differentiating y, it's just going to be dy dx. Okay, so we say dy dx. So this is how you differentiate this sort of term. Okay, if it is a product, remember this is the product rule. If you have difficulties with this, go back and view the lesson on the product rule and the quotient rules. Okay, for the quotient rule, of course, dy dx for quotients will be v, we hold the second function, and then we differentiate the first one, du dx, minus u dv dx Okay, we hold the first function now, and then we differentiate the second one, and then we divide by v squared. Okay, the function v squared. So this is the quotient rule. Go back and revise those, but this is what mainly you have to pay attention on. Okay, these key things. So first, to differentiate implicit functions, you differentiate the function term by term. Okay, and in differentiating term by term, do not forget the product and quotient rules. Whenever you have a product or a quotient, treat these sorts of terms as product and these ones as quotients. Okay, and then the second step is for you to make dy dx the subject of the formula. Right, let's try one example so we can see. We have this question here. I hope we have enough time to be able to complete this. So we are given, say, we are given the implicit function x cubed plus y cubed is equal to 3xy, and we are asked to differentiate it. To differentiate this, we say step 1, so say solution. Sorry, I'm racing against time for this one, so so step 1, we say differentiate term by term. Differentiate term by term. Okay, so what we do, we differentiate x squared, and then we differentiate y squared, and then we differentiate 3xy. Remember, 3xy is a product because we are multiplying x and y, right? 3, you treat it as a constant, as normally. Okay, so just forget about it. So let's go on and differentiate this. We say this will be 2x plus this, we say 3y squared dy dx, as I explained earlier. Okay, equal to, we say this one now, this is a product. So first we hold the second function, we hold y constant, and then we find the derivative of x. Okay, so holding y constant, x will be we assume there is 1 on top, so we multiply by 1 and then we subtract by 1. So this will be 1 minus 1 is 0, and any number raised to the power 0 is just 1. So 3 times 1 is just 3. So this will be 3 y times 3. Okay, y times 3, which would really be 3y because it's the same. Yeah, and plus, now we hold the first one constant, so 3 will always be there. Let's just leave the 3 there, and then 3, we hold x constant, and then we multiply by the derivative of y, and we know the derivative of y is dy dx for implicit functions. Okay, now our task, step 2, make dy dx the subject, okay, of the equation. Let's have some more space. So we make dy dx the subject of the equation. Okay, so what this simply means, we are trying to isolate dy dx on one side. So let's collect like terms. Okay, if we already have this can go onto the other side. Okay, while this one this comes to the other side, right? So let's just say we already have 3y squared dy dx here, 3y squared dy dx. Okay, if plus 3x dy dx comes over, the sign changes to negative, so it goes minus 3x dy dx is equal to, we already have 3y here, 3y. When plus 2x comes over, it changes to minus 2x. Okay, so now let us factorize dy dx. So dy dx, we take it out, and what is remaining inside, we have 3y squared minus 3x, this one. Okay, this is equal to 3y minus 2x. Okay, so we divide both sides by 3y squared minus 3x by 3y squared minus 3x. Okay, so this cancels. Let's get some more space. So we have dy dx is equal to 3y minus 2x over